Hi, we have come to question number 2. Question number 2, we are given two graphs. The first graph is y is equals to mod h of x. The second graph is y squared equals to h of x. Now, we are asked to explain why h of x is smaller than 0 for values of x for x between minus 1 and 2. And later on, we are also asked to sketch h of x for x that is greater than minus 3. Now, before we begin, let's look at what are the possibilities of h of x if this graph is not given to us. Or I would rather say that some possibilities. Now, one of the possibility is this. All right, is this graph itself is a possibility. H of x is like that, then you mod it is also like that. This is really one possibility. Now, it can also be like this. Okay. Now, what other possibilities? It can also be of such. All right. Now, there's probably a couple more. Now, after we understand this, then now let's look at the question itself. Now, why h of x is less than 0 for x between minus 1 and 2? Now, we are given y squared is equals to h of x. Now, what does that mean? That means y, this graph is y is equals to square root or plus minus square root h of x. Now, if you look at this portion of the graph, y is not defined for values between 1 and 2. And yet, for mod h of x, there are values. Now, the reason is very simple. H of x must be negative because we can't square root a negative number. It is not defined for a real solution. So you find that this portion, there's nothing in this portion for square root h of x. Now, that means I've already explained to you. Now, since plus minus square root h of x is not defined for values between for x between minus 1 and 2, implies that h of x is less than 0. Now we move on to the sketch of h of x. Now, how do we sketch h of x? Now, this is mod h of x. Now, when you do a mod function, the negative values will become positive, whereas the positive values will stay put. Now, you look at this graph. We know that this part is negative for values between minus 1 and 2. All right, and so this part of the graph should be like that for h of x. How about these two portions? Now, these two portions is defined. All right, for x values between minus 3 and minus 1. square root h of x has two parts, a positive and negative. That means h of x must be positive. So this part of the graph stays. And likewise for x values greater than 2. So the sketch of your graph will look something like that. Let me use a different color. You got -1 here and 2 here. So this graph, this is an asymptote, alright? This is not a quadratic graph because a quadratic graph does not have asymptote. And this will be 1/6 and -2/3. Mod h of x, this is 1/6 and 2/3. So if this is the h of x, all right, so this part should be 1/6 and -2/3. For that, let's look at part B of the question. We have now come to part B of question 2. Now part B, you are asked to give the sketch of f prime h prime x, that means the derivative of h of x. And also you are asked to sketch 1 over f of x, h of x. Now in both of the graph, you are asked to also show or states the coordinate of the turning points and also its asymptotes. Okay, now we shall start off with sketching the graph of h prime x. Now let's look at this. I purposely draw it one above another because it's actually easier to see, because if we draw it in line. Now let's mark out the critical region. Where it cuts the x-axis is a critical region. So let's say I mark this as a region. Turning point is another one. And this is. Now, you look at, we learned in secondary 4 or secondary 3 that now when your graph is slanting this way, it has a positive gradient. When it's a horizontal, the gradient is 0. This way is negative. Now, you look at this part, all right? The left-hand side of this region. Now, this portion, the gradient is negative, all right? So it must cover the negative part of the y-axis or h prime x-axis. That means it will not be in this region on the left of the turning point. Now how about this? This part, the gradient is slanting this way, so it's positive. So it will not be in this shaded region. Then you look at this portion. This is very steep. That means the gradient is negatively large. It will be somewhere very steep. It will be tends to infinity. That means it's going towards going down, steeply down. And here is a turning point. So the gradient is 0. Here is not as steep as this. So your graph eventually will look something like this. Alright, this part tends towards is getting closer and closer to the line x equals to -3. So this is an asymptote. Alright. And now this part will be 1/6. Alright, the x coordinate is 1/6. Okay. Now we will move on to the graph of 1/h of x. Now same thing, let's mark out the critical region. This will be one of them. Turning point. This one. And also the x-intercept. Now let's move from left to right. Now for 1/h of x, when you do a reciprocal, it does not change the sign. Alright, if it's a positive, it will still remains as positive. So for this region, alright, it will occupy the positive portion. So it will not occupy here. Alright. This part, it will occupy the negative region. So same as here. Alright. So all this, it will occupy the negative because it doesn't change sign when you flip the graph. Here is positive. Alright, so it will not occupy this region of the graph. Now let us consider the critical point. Now this is positively large. When you 1/, a positively large number, the number will be very close to 0, but it still remains as positive. So it will be somewhere here. This is very close to 0. Now let's take this point here, very close to 0, but positive. When 1/, a very small number, of 1/, a very small positive number, all right, like let's say 1/, 0.001, right, the number becomes very huge, will tends to infinity, will be somewhere here. Now then let's move on to the next one. Now this is negatively small. I mean, let's say this is -0.01. All right, when you do a reciprocal, this will be negatively large. All right. Now this point, the x coordinate will still be the same, whereas this point will be -3/2 when you reciprocal. All right, this is 1/6 minus 3/2. That is this point here. Okay. Now this is let's say we take a point that is very close to 0 but negative. Like I say -0.01. When you reciprocal it, all right, that will be negatively large. All right. Now same thing over here. You take a positively small number, 0.001. Turning around, it will be very huge. And likewise for this point here. So your graph will look something like that. All right. Now, this is an asymptote, so it does not touch -3. So this is a open 0. It does not touch. And this part, it will look something like that. And this one will be like this. Now, so what is the asymptote? The asymptote here will be x equals to minus 3. This is minus 1. So the other asymptote will be x equals to minus 1. And this part will be 2 here. So x will be equals to 2. So these are the vertical asymptote. And this will be the turning point. For that, we come to the end of question 2.